Hey, this is Brian, and I'm going to do a quick recap of exam number one. And I'm not going to focus on the solutions. I'm going to focus on what are the lessons that we can take away from it. And here's the first one. Here's how people did. Okay, this is kind of our curve of the distribution. And on the whole, folks did pretty well. And I'm going to come back to this in a second and look at the distribution. But first, I want to remind you of the big picture grade in the course. Now, there are 300 points total that are available in the course. Half of them are effort-based. That's based on the labs, the quizzes, the homework, etc. That's worth 150 points. Now, you might not have started out this way, but if you continue to improve, you can expect to get 5 out of 5. If you're putting in the effort and you're following the feedback and you're kind of like making good progress, you can get 5 out of 5 on all these different assignments. That is within your grasp to be able to do it. So you could conceivably, and a lot of people will, get 150 out of 150 points on this section of the course. Remember, you can drop your lowest 2 lab grades, your lowest 2 recitation grades, your lowest 2 homework grades. So this is an achievable goal. Now, on the other end of the puzzle, we've got the holistic grading, and that's what we do for exams. And the exams, we do holistic grading. We've got a rubric that we follow. And so when we look at an individual score, we don't take off. Okay, we do not talk about taking off points for mistakes. We do not do that. No, we don't do that. What we do is we check for understanding. And we give you a grade on a 1 to 5 scale based on your understanding. Do you know what you are doing? And you can get the wrong answer and still get 100% credit because we're really focused on the process. Like, I don't care if you get a particular problem right, but I care deeply that you know how to do physics and how to talk physics. And so that's what we're checking for. We're looking for your understanding. Now let's look at the final course grades that folks are going to get. Okay, if you have 90 to 100%, that is an A. So 270 to 300 points. The B range grades, okay, they're the 80 to 90%. So they are in the range of 240 to 270 points. C range grades are in the range of 210 to 240 points, okay? And then less than that, let's not talk about those right now, but we will come back and have some things to say about that later. Now let's take a look at the course grades. And let's suppose that you're able to get 150 points on your effort-based scale. And as I say, that is an achievable goal. If you are willing to work, this is within your grasp. This is absolutely possible to be able to do this. And certainly if not 150, you can get close. So the exams, exam number 1 is worth 25 points, and exam number 2 is worth 25, exam number 3, exam number 4. Exam number 5, which is our final exam, is worth 50, okay? So that's a total of 150 points for all of the exams. Let's suppose you got a 20 on the exams. If you get all 20s, 20, 20, 20, and 20 is 80%, 80% of 50 is 40, you get a 40 on the final, that puts you at 270. That is an A. So I look at grades, they're 20 and above, so greater than 20, I say those are an A. 20, 21, 22, 23, 24, that is an A range grade. If you get all 15s on the first 4 exams, and then you on the final exam, which is worth twice as much, you get a 30, that puts you in the range of a 240. That's a B range grade. So I look at 15 as a B range grade. You're going to look at that and say, oh my gosh, that's 60%. That's an F. I look at it and say that's 60%. That puts you on track for a B if you're willing to do the work to get all the points on the effort-based grading scale. Now, if you get 10s, and I get all 10s, that's a 40%, and I get 40% in the final, that's 20. That's going to give me a total of 210, assuming I get 150 for my effort-based grades. That puts you at a C. That puts you at a C. So I look at your grades and I say this. I say if you're getting something in the range of 20 to 25 and you're doing all the other work in the course, you are on track for an A. If you're getting grades that are like 15 to 20, you're in the B range. If you get grades 10 to the 15, you're in the C range. If you're getting less than 10, we need to talk because whatever you're doing is not giving you the degree of success that you want and that I want for you. And so we need to figure out some sort of a strategy. So let's take a look at the problems on the test, and I'm going to tell you what we were looking for. Okay, so here's this one here. It was called What a Dive, and this is about falcons executing high-speed dives to catch prey. And you're given a graph of the speed versus time for the falcon. Now, what were we looking for? What were we looking for? And I want you to go look at the complete worked out solutions, but I just want to tell you how we graded. And first off, we said, look, if you're strategizing, and remember, I care deeply about how do you set up problems? How do you solve them? When we're strategizing, okay, we're going to say there are two phases to this motion. And this was vitally important. You needed to know this, that I had a period where the motion was constant acceleration, and then I had a period where the motion was constant velocity. And if I'm solving for distance, what I need to do is I need to compute the distance one way for this segment. I'm going to compute the distance a different way for this segment. So we needed you to do some strategizing and to say there's two phases to the motion, okay? Next, for the prepare step, okay, we wanted you to do that. We wanted you to say, okay, let's look at this. Let's look at this. For the first phase, for the acceleration, I can compute the acceleration as delta v over delta t. Now, a lot of folks said that, but delta v, that's the change in time over the time interval. So it doesn't change from 0 to 20. It changes by a total of positive 5 meters per second because it goes from 15 to 20. And the time interval for that to happen is 0.67 seconds. We needed you to kind of like know that and know how to use those kind of acceleration calculations and figuring out accelerations from a graph. Now I'm going to show you completely, oh, by the way, too, and then we go on to like solve and we go on to assess. Okay, that's cool. I do want to say something about the assess step because we absolutely paid attention to it. And one of the things that I saw people doing on the test, which was something I would prefer not to see, is everybody just basically said, that makes sense. Now, we had people who got numbers in the range of a few millimeters, and we had people who got distances in the range of a few kilometers. And neither one of those makes sense, okay? Neither one of those things makes sense. I mean, a falcon in a dive in 1.5 seconds is going to travel more than a few millimeters, and it's not going to be able to travel a few kilometers. These do not make sense. We want you to really look at your numbers and see if they do make sense. And if you made a mistake and you said, hey, that does not make sense, if you said that doesn't make sense, that was good because it showed understanding. So if you made a mistake and you realized it, that's fantastic. That's fantastic. You won't necessarily have time to go back and fix it on the exam, but the fact that you realized it, that is a good thing. Now you notice I'm not talking about the solve step at all. For this, you can look at the posted solutions. I'm going to post solutions to the exam. Go ahead and take a look at those, and you can kind of like evaluate how you worked looking at the posted solutions. I'm not going to talk about them here because I really want to stress we really paid attention to your strategize step, your prepare step. We paid attention to your assess step. We pay attention to your understanding. And it's these pieces that show us, do you understand what you are doing? Or are you just sticking numbers in equations? And if you're sticking numbers in the equation, that is not doing physics, okay? That is doing algebra. We want you to do physics, so we're looking at your understanding. Now, there was a completely different way that some people did it, which was kind of awesome. And some folks said, oh, we solved a problem on the homework assignment where we were looking at how far something traveled, and we just found the area under the curve. And you could do that too. And if you did that and said like, hey, I'm just going to find the area under the curve, that gives me the distance. I'm going to break it up into a triangle and a rectangle and another rectangle. Like we would say, good on you. That was fantastic. That was another way that you could do it. Next problem. There was this one here that was called stick the landing. Okay. Now you look at this. Okay, we're using force plates. Okay, you're given data about force. Okay, we're given data about force, and then we're ultimately supposed to calculate some sort of a speed. How fast was the person moving? This is critical. This is critical. We want you to strategize. And we wanted you to say something about like, look, we're going to find F net. We're going to use that to find the acceleration, and we're going to use that to find a velocity. So establishing some sort of a strategy was crucial for us. Tell us what you were doing. If you just grab an equation and start sticking numbers into it, you were likely to not end in a happy place. And we also wanted people to prepare. And you know what we want you to do for the preparation. We want you to draw a free body diagram. Draw a free body diagram. If you did that, and you said, look, there's a weight force which is acting downward, and there's a normal force which is acting upward. And it's a 61 kilogram person, so the weight force is about 600 newtons. The normal force, reading from the graph, is 1800 newtons. The net force is equal to N minus W is equal to 1200 newtons. If you did that, we're like, okay, we are in the hands of somebody who knows what they are doing. If you did this prepare step, that was crucial. And we were particularly impressed if you also coupled that with a free body diagram. You said, look, the person's moving downward at some speed when they first touch the plate, but their speed decreases. They slow down as they go. They slow down as they go. And ultimately they come to a speed of 0. And so they begin at a speed, initial speed, which we're looking for. They finish at a speed v final, which is 0. In between, there's an acceleration, which is in fact positive. And we're looking for that acceleration. If you did that, that would be fantastic. And then for solving, of course, you're just going to use Newton's second law, and you can figure out the acceleration. Knowing the acceleration, you could find the velocity. But we paid particular attention to this. Now, the easiest way to show us you know what you're doing is to draw a free body diagram. If you draw a FBD, a free body diagram, that was told us, like, you know what you're doing, and then you subsequently did this kind of calculation. That was great. Now, you didn't have to do that to get full credit, but it certainly helped us to know what you're doing because, as I said, we're assessing your understanding. Now, the most common thing that I saw people do, and this just made me sad, the most common thing I saw people do was said, oh, A is equal to F over M, and V is equal to A times delta T. Now, those are both equations which are absolutely true, but you have to know what these equations mean. This is vitally important. And if you just put in the force was 1800 newtons, no. That's not true. This is the net force. And the net force is not 1800 newtons. The net force is 1200 newtons. And you get to that by doing the free body diagram. So if you did this, what you were likely doing was taking equations that you know, looking for numbers in the problem. You're saying like, oh, look, I've got a mass. Oh, look, I've got a force. Oh, look, I've got a time. I'm just going to stick those numbers in the equations. No, that is not the path to happiness here. What we need you to do, is to go ahead and do your free body diagram, set the thing up, figure what's happening physically, and then the equations practically suggest themselves, okay? So if you did this, that's a pretty major error because you've said like you haven't prepared. You haven't thought about the problem. You're just taking an equation, you put numbers in the equation, and that's not a happy outcome. Now the next problem, and there was a hint in the title, is called relatively speedy. Okay, and so we wanted you to treat this as a problem of relative motion. And we were impressed if you said that. If you said, oh, it's relative motion, that's good. That's part of your strategy. Otherwise, you're just putting numbers in equations. And we need you to strategize and say, this is a relative motion problem. You are given the speed of the athlete relative to the ground. You were given the speed of the javelin relative to the ground, and you're looking for the speed of the javelin with respect to the athlete. This is a relative motion problem. And some folks said, isn't this a lot like Anita? And it was like Anita. We did a couple of problems on homework assignment and the recitation, and also we talked about it in our in-person section in class. So if you made that connection, that was a plus because it said you understand what's going on. You've identified the type of problem. You have established a good strategy. And if you establish a good strategy, even if you're not able to complete it, that tells us that you know what you're doing. And the ultimate was for people to say, look, the speed of the javelin with respect to the ground is equal to the speed of the javelin with respect to the athlete plus the speed of the athlete with respect to the ground. If you did that, if you wrote down a relative motion problem, That was awesome. And that could be part of a prepare step. You didn't have to label it, but we wanted you to have something like that here to say, I've got some sort of a relationship which describes the relative velocities and relates them to each other. And we were looking for that. We wanted you to be able to make that sort of analysis. And with that in hand, you could do your final calculation. You could get the final result right and not get full credit. Because as we've said before so many times, what we're testing for is your understanding. And if you just guess at the answer, or if you just kind of like think about it and kind of like evolve it out of your consciousness, that's cool. But we're interested to know, do you understand what you were doing? Do you know how to do physics? And so we wanted you to say something about this. We wanted you to write some sort of equation. And we wanted it to be the kind of equation that we saw previously. That's what we were looking for. Now let's take a look at the next problem. And in this one, just a fling. Okay, in this one, we have the things that impressed us the most was we saw people who had a great strategy. There's a great strategized step. And they said, okay, look, we're going to treat this as motion with constant acceleration. Because you're asked to find an acceleration, you're given an initial and a final speed. You're given a time. We're going to figure out an acceleration, and we're going to be figuring out the distance that it moves. So folks said the strategize is great, and then a few folks prepared it and said, look, I've got this little thing, and it starts at a speed equal to 0, and it finishes at a speed of 0.16 seconds. And when folks did this, we looked at this and we said, or 0.16 meters per second. When we looked at that, we said, this is a person who knows what they're doing. They wrote down the initial time, they wrote down the final time. They could use that to calculate the acceleration. With the acceleration, they could calculate the distance. But if you set it up this way, if you did your strategize and you did your prepare, we looked at that and said, you know what you're doing. And even if you got the answer, final answer that was wrong, that was fine. That was fine. We wanted you to be able to set it up. We wanted you to be able to set it up, and that's what we were paying attention to. Okay? And so again, pay attention to that setup, because that's what we're assessing. We're looking for your understanding. And if you've just taken numbers and stuck them in equations, we don't know that you know what you're doing. You have to explain that to us. Now, the final problem was this one, lean into it. And what we were looking for was a free body diagram. And the kinds of things we were looking for was you to say something like this. Okay, if I look at this, and I'm doing some sort of a strategize, I'm drawing a free body diagram, but I'm going to say like, okay, let's do some strategizing. Let's think about what our answer is going to be. Well, we know she's not going anyplace. Since she's not going anyplace, F net has to be equal to 0, and that better show in your diagram. Okay, you know that it has to be true. We also wanted you to say, okay, I know something about the forces between surfaces. If I got two surfaces or something in contact with the surface, I can have a normal force, which is perpendicular to the surface, and I can have the friction force, which is parallel to the surface. We wanted you to know that about normal forces and friction forces. We also wanted you to know that the weight force is always directed straight down. And so we wanted you to have some sort of a diagram that illustrated that. Also, too, we wanted you to know that you have to have agents and objects. We're looking at the forces that act on the person. And so some people wrote down like the force of the girl on the wall. Okay, well, that doesn't matter because that's the force of a person on the wall. We want you, first off, to identify what kind of force, but also, too, that's not useful here. We're looking for the forces on the person leaning against the wall, so it can't be that. So we wanted you to say, look, there's two things that exert forces on her, okay? There are the floor, because she's touching the floor, and there's the wall, because she's touching the wall. And each one of those can exert normal forces and friction forces. And then there's also the weight force. So I've got normal forces, friction forces, weight forces. We wanted you to come up with a diagram that illustrated that. And so I want you to pay attention to thinking about how do you set up problems and how do you demonstrate that understanding, okay? Now, here's my takeaways for this. First off, focus on the process, not the equations. Don't just find equations and stick numbers in them. And then focus on your understanding, not the solutions. You don't have to get the right answer to get full credit, but you have to show us that you understand what is going on to get full credit. As I was grading, I had people who got the right answer who did not get full credit. That doesn't equal full credit. I had people who got the wrong answer, whose final answer didn't match mine. That's okay. If you had full understanding, and I could tell you knew what you were doing, but you dropped a factor of 2, or you kind of like made a minor conceptual area, that's okay. Full understanding equals full credit. So I want you to focus on the understanding, not the solutions. And long term, that's the process that's going to make you a better problem solver, a better person at doing physics. And that's what we're interested in. We're interested in making you better at doing physics. And physics is something you do, not something that you know. Final takeaway, I want you to remember this. Sometimes people, they get the first test result back and they're discouraged. I don't want you to be discouraged. I want you to be challenged. If you didn't do as well as you wanted to, you know what it takes to do better. We want you to read the textbook. We want you to participate. We want you to think carefully about what you're learning. Like, what are you doing? What are you doing? What are you learning to do? You're learning to solve problems. We want you to follow our strategies. We want you to be critical about your learning process. We want you to pay attention to the feedback that we give you, okay, and use that to improve. If you do that, if you do all of this, if you keep working and keep improving, you can do better. And remember, a couple of things. This exam is less than 10% of your total course grade. You could get a 0 out of 25 on the exam, and you could still get an A. That is possible. It'd be hard, but it would be doable. So don't let this one grade define you, okay? You're defined not by your grades. You're defined by how you respond to the circumstances that life throws at you. And if you didn't do as well as you wanted to, well, put the effort in to do better. Remember, this course is a marathon. It is not a sprint. We are in it for the long haul. We're going to just keep working. We're going to double down. We're going to put in a little bit of extra time. We're going to complete our homework assignments early. We're going to come to problem sessions early in the week. We're going to read the textbook. We're going to watch the annotated slide videos. You know what needs to be done. And if you keep working, you will keep improving. And if you will keep improving, you'll learn how to solve problems. You will get the grades that you want. So the class as a whole did great. Class as a whole did great. I am very, very pleased with how everybody did. I would like to see everyone continue to improve. Is everybody perfect? No, of course not. That's why you're here. If you already knew how to do physics, you wouldn't be taking the class. You are going to make more mistakes. There are a lot more things to learn, but I want you to keep working, keep improving, and doggone it, I will commit that the GTAs and the LAs and we are with you. We are with you every step of the way. We are going to help you get to where you want to be. You aren't doing this alone. Finally, if you're just not feeling it in this course, if it's difficult, if you're having any problems, reach out to one of us. We care so deeply. I care deeply about the success of everybody in the class. Reach out to us. We are here to help you. We want to see you succeed, and we'll do everything we can to help you do that. So take a look at this. This gives you some pointers on how to set up and approach the problems. And we hope you take these things to heart. And we hope that this exam was a good experience and the next exam is even better. Thanks much.